Welcome back to Infra Explained, Episode 5, and today we're tackling the thing that trips up almost every Kubernetes beginner, pods and containers. If you've come from Docker, you probably expect to just hand Kubernetes a container and call it a day. But that's not how it works, and in the next few minutes, we'll untangle exactly why and where the pod fits into the bigger picture of container, pod, node, and cluster. So here's the wall almost everyone hits first. You've just gotten comfortable with Docker containers, and then Kubernetes tells you, no, you don't run a container. You run a pod. And before you've even processed that, tutorials are throwing nodes, replicas, and deployments at you, and it all turns into mush. The good news? There's really just one hierarchy worth memorizing. A container goes in a pod runs on a node, and nodes form a cluster. Lock in those 4 words, and most of the fear goes away. So let's nail down that first word, pod. In one sentence, a pod is the smallest thing Kubernetes actually runs. Think of it as a thin wrapper around one container, sometimes a couple, that all share the same network and storage. That's the key shift. Kubernetes doesn't schedule containers directly, it schedules pods. In practice, it's almost always one container per pod, and anything inside that pod shares everything. Same IP, same volumes, same little world. Now zoom out, and the whole mental model fits into 4 nested boxes. A container lives inside a pod. The pod runs on a node, which is just a machine, physical or virtual, and a bunch of nodes together form the cluster. The nice part, you don't pick which node runs what. You hand Kubernetes a pod, and it figures out where to place it. That's really the whole shape of the thing. So, a fair question at this point, why wrap a container in a pod at all? Why not just schedule containers directly? A few reasons. Kubernetes wants one clean unit to place, restart, and track, and the pod is that unit. It's also a shared space. Anything inside it gets the same IP and the same volumes, like roommates on one host. That means you can drop in a helper, a sidecar for logging, or a proxy right next to your main container. And the pod itself carries the labels, health checks, and lifecycle rules. In practice, most pods hold exactly one container, but the pod is still the consistent box Kubernetes reasons about. And here's what that box actually looks like on disk, a small chunk of YAML. Same declarative style we used back in the infrastructure as code episode, kind pod, a name, and underspeak, the container we want. Nginx 1.207, listening on port 80. Notice what's missing. There's no which node, no how to start, no restart logic spelled out. You're just stating what should exist, and Kubernetes works out the how and the where on your behalf. So how do you actually hand that YAML to the cluster? With kubectl, think of it as your remote control. You apply the file to create the pod, then get pods to see it running, logs to peek at what it's saying, and delete pod when you're done. That's the whole rhythm. Describe in YAML, drive with kubectl. Now that you can drive pods around, here's the mindset that trips up most people coming from Docker. Pods are cattle, not pets. You don't SSGin and fix a broken one. You let Kubernetes shoot it and start a fresh, identical copy. They're created on demand, replaced when they crash, scaled by just running more copies, and crucially, they hold no important state inside. Anything you actually care about lives somewhere else, and we'll get to where soon. Which is exactly why, in practice, you almost never write a pod, YAML, and apply it directly. You write a deployment, a small spec that says something like keep 3 copies of this web pod running, and Kubernetes takes it from there. It creates the pods, watches them, and if one dies because a node crashes, it quietly spins up a replacement to get back to 3. The pod is still the unit. The deployment is just the manager making sure the right numbers stay alive. So let's put the whole family on one board. Your container is just your app packaged. The Docker part you already know. A pod wraps one or more of those containers into the smallest deployable unit. A replica set keeps a fixed number of identical pods alive, and a deployment sits on top of that, handling rollouts and updates. a service gives those pods a stable network address, since pods themselves come and go. And underneath it all, the node is the actual machine where these pods run. Learn the pod, and everything else just slots in around it. Now, I said a pod can hold one or more containers. So let's talk about that. Honestly, 95% of the time, it's just one. Your app wrapped in a pod, done. But every so often, you'll see a second container riding along, a logging agent, maybe a proxy. That's the sidecar pattern. Because they share the pod, they share the network, which means the sidecar can reach your app on plain local host. Same pod, same loopback. That's the whole trick. Before we move on, let's clear out 3 myths that trip almost everyone up. First, a pod isn't just a fancy container. It wraps containers and gives them shared network, storage, labels, and a life cycle. Second, don't cram your whole app into one pod. Each service gets its own, so you can scale them independently. And third, pods are not permanent. They're disposable by design, spun up and torn down constantly, so any real state belongs outside, in a volume or a database. So, with those myths out of the way, here's the short list of habits that'll keep you out of trouble. Stick to one container per pod most of the time. Let a deployment manage them instead of creating pods by hand. Push any state out to a volume or database, and always set resource limits and health checks. And on the other side, don't cram multiple apps together. Don't store data inside the pod. And don't treat pods like servers you nurture. They're cattle, not pets. Now, knowing the rules is one thing. Actually working with pods means living in your terminal, so let's talk tools. There are really just 6 kubectl commands that'll carry you 90% of the way. Get pods to see what's running, describe to dig into the details and events when something's off, logs to read what your container is saying, exec-it to drop into a shell inside the pod, apply-yef to create things from a YAML file and delete when you want it gone. Learn these 6 and you can navigate almost any cluster. So let's pull it all together. A pod is the smallest thing Kubernetes actually runs, and it sits inside that hierarchy we keep coming back to: container, pod, node, cluster. Containers sharing a pod also share network and storage, which is exactly why you put tightly coupled processes together. Pods themselves are disposable, so keep any state outside of them. And when you need a certain number running at all times, that's what deployments are for. If you take just one mental model away from this whole series, make it this: the pod is the box Kubernetes actually holds on to. Your container rides inside it, and Kubernetes schedules, heals, and scales the box, not the container directly. So instead of asking, where do I run my container, you start declaring a pod and letting the cluster decide where it lives. That shift from container thinking to pod thinking is really the whole game. Once that shift clicks, the rest of the catalog suddenly lines up around it. Your Docker image, it gets wrapped in a pod. Infrastructure as code, you're writing pod definitions in YAML. Networking, services exist to give pods a stable address because pods themselves come and go. And hardening, pod security is rule number 1 in Kubernetes. So that high-value skill, understanding the pod, finally has a place to stand in every conversation you'll have about infra. So if you want to keep going from here, the Infra Explained series walks the same path in more detail: Docker, Kubernetes, CI/CD, infrastructure as code, and of course pods and containers. And once pods feel like home, the natural next step is locking them down. RBAC, pod security, network policies. That's what the Kubernetes Hardening Mastery course over at Dargslan.com covers. Before we wrap up, I'm genuinely curious. Did the whole pod versus container thing finally click for you? Be honest about it. How long did Kubernetes' vocabulary trip you up before something snapped into place? And which term gave you the most trouble? Drop it in the comments. I read them. And that's usually where the next episode's topic comes from. And that's the wall coming down. You started not sure what a pod even was, and now you've got the full picture: container inside pod, pod on node, node and cluster, plus the vocabulary to actually run, scale, and secure real workloads. If this helped, hit subscribe for more infra deep dives, and you'll find the rest over at dargslan.com. Thanks for watching.